It is very important that we note that we can use our peripheral devices or they are classified in these three ways. Over here, I have a diagram. The diagram here shows the control signal from the I/O model, the status signal from the I/O model, the data bit to and from the I/O model, and then the control logic, the buffer, transducer, the data to and from the environment. This diagram here shows you a block diagram of a peripheral device. It shows you how it is connected, how it picks data from one point to the other, and how it transfers the data that it uses. Control signals determine the function that the device will perform, such as send data to the I/O unit or accept data from the I/O unit. It is going to use status signals to indicate the state of the device. That is, if the device is ready or not. It is very important that we realize some certain points here that the peripheral devices are connected to the computer, true, but we have to find a way whereby the computer can know its status, if it is there or if it is not there, if it is ready to receive data or if it is not ready to receive data. For example, over here, over here, simply when I enter 78, for example, minus let's say 56 or whatever I've typed in here, and I press enter, the computer has to know some certain things. One has to know, okay, is there an input device ready for me to accept the input I am typing? Is there also an output device ready for the thing to be displayed? Of course, when it is done and it has to output with the results in which it has, and there is no output device for it to output this, it's a very, very big problem in that case. Hence, it is very important for the computer to know that the devices in which it wants to output, they are there and ready for it to do that output. It's also important to know that it does this by sending in bits as signals. So it will send in a one or a two or a three or a four. Normally, it is because it's a bit, it's going to be ones and zeros anyway. So there, so that the computer will know that, oh, if it is a one, then that means it is ready. If it's a zero, then it's not ready. If it's a one, then it is dealing with something, so it is not ready for you now. So you wait a bit, so on and so forth. It uses those signals to translate or to tell that, oh, the device is ready or not, or the device has something to do or not. If you have, by the way, if you have any question to ask, raise your hand so that you'll be asked because some of you, for some reason, don't know that you don't have to um, unmute your mic. So if you have a question to ask, just raise your hand and I will call you. Yes. So examples of input devices. Examples of input devices, we have a keyboard, we have an optical input device where we have the card reader, the tape, the, the paper tape reader, the OCR, the OBR, that is the optical barcode reader, the digitizer, and then the optical mark reader. We have the magnetic input devices where we have the magnetic strip, reader, and then the magnetic ink character recognition. We also have a screen input device that allows you to do touch screen, light pen, and then of course we have our mouse. Then we have analog input devices. These are all examples of uh, input devices. When we have output devices, then we have our keypad, our card puncher, our paper tape puncher, our monitor, our printer, our plotter, and our analog and voice devices. These are all examples of output devices. For the input-output module itself, it is an interface in which we use to control the the actions of the I/O devices. So the input-output modules interface to the system bus or central switch interfaces and controls to one or more peripheral devices. So it sits between the peripheral devices and then the computer. Also, we must note that the peripheral devices, they come in many forms. They are from many companies. They are from many, you can have a Samsung, a HP, an iPhone product, or the devices can be plenty. So in there, there is the need for the modules to, one, make sure there is standardization in all the devices, make sure all the devices have the same standard in which they work from. Also, it is very important, they are very important because they are there to do a job, which is to communicate between the input device and then the computer itself. Hence, they being there allow you to translate from machine language to the language in which you would see on your screen, or from the language you see on your screen to machine language for them to also use. And they also serve as the bus system that also tell you if the device is ready or not, if the device is ready to go, is not ready to go, those kind of things. They control all of those. So they are very important. So as we can see, we have the bus system here, where you have the address lines, the data lines, and the control lines. So all of these have their own routes in which they use to translate data between them. Also, we have the input module itself, whereby all the peripheral devices, as you can see from this point here, where my cursor is going around, are connected. They connect to the module, then the module will connect to the bus lines. So it is the module's job to go to the bus lines to send it to whatever signal that it is needed at that point in time. And note that it is not only the CPU that the bus lines go to. They can go to the light indicator to show that, oh, there is a problem here or there, or whenever you click on anything, the lights will show on your screen. They can go to them to also give responses from there because they are also feedback. And also, those lights are also part of the output device. So they also give feedback to you, hence they are also output devices. So peripheral devices are not directly connected to the system bus. Instead, an I/O module is used, which contains logic for performing a communication between the peripherals and the system bus. The reasons due to which peripherals do not connect to the system bus are as follows. Number one, they are a wide variety of peripherals with which methods, with various methods of operation. So, as I said in the explanation I was giving earlier, the devices which are coming are plenty. They are different manufacturers, they have different ways of doing things. But when they come to your computer, there has to be a standardized way in which the computer can read that piece of information. Hence, the system bus line, sorry, hence the I/O module, its job is to make sure that across board, all of them have the same standard to be able to work well with your computer. The data transfer rate of peripherals is often much slower than the memory processor. Thus, it is empirical to use high-speed system bus to communicate directly with the peripherals and vice versa. So technically, it's like this. If, let's say, your system's processor is so fast, so it processes speed at a very fast rate, it having a buffer will allow you to control the rate in which it transfers data. You can tell it that, hey, slow down. The USB that is coming is 2.0, so you slow down. Okay, it is 3.0, so you can go faster, so on and so forth. Peripherals often use different data formats, word lengths than the computer to which they are connected. Again, coming to different manufacturers or even different devices themselves. If you plug up a pen drive, if you plug up a hard disk, if you plug up a SSD drive, you would realize that the rates at which these things are transferred are very, very different. Hence, the words which are sent to and from the device to your device are also very different. Hence, it is the job of the I/O module to control this and make sure there is standardized transfer of data between all the devices which are available. What are the functions of the I/O module, or what functions does the I/O module play? The I/O module is a special hardware component interface between the CPU and the peripheral devices to supervise and synchronize all I/O transformations. The detailed functions of the I/O module are as follows. One, they are there for control and timing. They are there to make sure that everything is done on time, even if the devices are not at the same speed, even if the devices are not transferring data at the same rate. Its job is to make sure that the transfer between the two are always on time and they are always perfect. I/O models include control and timing to coordinate the flow of traffic between internal resources and external devices. The control of the transfer of data and external devices to the processor consists of the following things. The processor interrogates the IOD module to check the status of a connected device. So whenever you plug up your pen drive, it is the IO module that will be contacted to see if the pen drive is connected, if the pen drive is working, and if the pen drive is ready for data to be transferred to it. Also, it is the IO module whose job is to return the device's status. Of course, if it is the IO module's job to check if the device is ready or not, it means it's the IO's job to also keep track of your current status. So, are you ready now? Are you good to go? Can we display something? Can you accept input? Are you ready to start typing? Have you started typing the input? All of these things, it is the job of the IO module to do that. If the device is operational and ready to transmit the processor requested, the transfer of data by means of command to the IO. So again, we see this definition here that it is the IO's job to check if you're ready and transmit the data that is requested by the processor. The IO module obtains the unit of data from the external device. The external device is going to have its own format that it uses. The external device is going to have its own standard that it uses. The external device is going to have a signature from the brand in which it is coming from. With that in mind, it means that it is the job of the external, is the job of the IO to make sure that the device meets the standard of the computer that it is coming into. So you can see that no matter what generation the computer is from, or no matter what time your computer is being manufactured in, no matter what you plug in, so far as you have the correct drivers, they play, they work because the standard by the iOS will always be matched and always make sure everything is in sync. So it is also the job of the IO module to supervise the transfer or the transferring of data from the IO module to the processor. So the IO module does all of these things. Now, it is also there to do processor communication. So IO module communicates with the processor, which involves the following. It involves decoding of the command from the processor. It involves the exchange of data from the processor to the IO module over the bus line. It involves giving a status report like the peripheral device is slow. So don't pull the data quickly, relax so that you can match up with it, so on and so forth. And it is also there for address recognition. So it is the IO device's job to give a unique address to the peripheral device so that the computer can know where those devices are placed or they are kept. It involves commands, status, information, and data. That is device communication. It also involves data buffering and involves error detection. So again, just a quick go over, the IO model performs the following functions: control and timing, processor communication, data buffering, and error detection. So what is the structure of the IO model? The IO model has this structure here, where it has in itself internal registers. Why does it have registers? Because obviously, if it is going to keep track of what things are doing, it needs a place to store that information. So it is the internal register's job to store that piece of information. We have external device interface, whereby it uses to connect to the external devices. We have the I/O logic that it uses to control the bus lines and the address lines, and so on and so forth. So for it, it has all the tools it needs to connect to the computer and then do the job in which it is supposed to do. Are there any questions before we continue? There are no hands up, so I'm assuming there are no questions. So the input-output interface provides a method for transferring information between internal storage, such as the memory and the CPU, and external I/O devices. Peripherals connected to a computer need communication links for interfacing them with the central processing unit. The communication link revolves sorry, the communication links resolves the following differences between the computer and the peripheral device. They solve device and signals, peripheral electromechanical devices, CPU or memory, that is electronic devices. They resolve data transfer, they resolve units of information, and they resolve operation models. So again, if I have an interface, and when we talk about an interface here, for example, if you have your computer, then the interface we are talking about is your USB adapter or your Type C adapter or your Type C adapter or your connect the connectors you use the HDMI ports and all of those ports that you use to connect to external devices. Note that there are internal adapters to like the keyboard or the touchpad. They have internal adapters which are also connected there. So those interfaces, the job is not just to just connect the thing to the PC, it's to give it power, is to make sure that it is working well, to make sure that the data transfer is correct, and so on and so forth. So they have jobs to play too. So here we have a diagram of the input output and then the interface modules. So we can see that the interface modules connect to the bus lines. And then over here, we can see we have the keyboard, we have the printer, we have the magnetic disc and the magnetic tape. All of them have their own interfaces. So the places in which you plug them physically for them to touch the computer. So for example, if it was a pen drive, the USB drive stick that to connect directly to have interface with the computer. What jobs does the interfaces play? They do decoding or the codes, that's this point here, decodes the device address, decodes the commands, provides signals for the peripheral controller, and then it synchronizes the data flow and supervises the transfer rate between peripheral and CPU or memory. So it is the job for these devices to do all of those communication of devices as this computer is being used. Now, the I/O commands that the interface may receive. What are the I/O commands that the interface may receive? The interface may receive okay, sorry. So, what are the commands the I/O interface may receive? The control command issued to activate the peripheral, to inform it what to do, the status command used to test various status conditions in the interface and the peripheral, the output data, which causes the interface to respond by transferring data from bus into one of its registers, and input data, that is the opposite of the data output. So technically the data that is being transferred into the bus lines. So these are the commands in which the computer receives from its bus lines. Are there any questions at this point? For those of you who are busily writing your index number in the chat, I don't know why you're doing it because when the class started, I intentionally waited for 10 minutes and then for everybody to join. So all of you who joined in the first 10 minutes, I took attendance for just so that we have a fair world um, in your class group. Um, which one is your class group? This one, group C. In your class group, I have put in the attendance I took. At that point in time, I think there were 24 of you who were there. So all of you who joined 30 minutes late and 20 minutes late, you have no mark. So next time, when you come back in life, when you are doing something, you do it on time. That Ghana time thing, that the thing is 7 o'clock, but you come at 7:20 because being late is like the culture of the day. I don't see the point of that. So the whole writing your index number in the group thing, let's stop because it's becoming plaintext. Let's stop. There's no need. I've put the list, the group of names over there so that you can see. Next time when we have to do something, you come on time. This whole point of why to call the people to come. So let's stop. So over here we have I think next thing we have to discuss under the I/O devices, which have to do with the memory bus. And the memory bus is used to communicate information between the memory and the I/O. Now, it does this in three ways. Use two separate buses, one for the memory, one for the I/O. So for me to do the action of transferring information from my input output device into my memory, I can do two separate bus lines, one for information to the memory, one for information to the I/O, so that they can go back and forth. And in this method, all data address and control lines will be separate for memory and I/O. That means technically I'll be having 6 lines for them. Number two, use one common bus for both memory and I/O, but have separate control lines. There is a separate read and write line. So there will be an input read and an output read for I/O, and a memory read and a memory write for memory. So for this one, there is a common line, but when it comes to the control lines, they would be what? Separate. And the last one is we are going to use a common bus for memory and IO, which with a common control line. So it means that for this one, all of them are going to use the same control line and the same bus line for the devices in which they do. So for devices in which they do. So isolated IO versus memory mapped IO. The isolated IO separates IO write and read control lines in addition to memory write and read control lines. Separate memory and IO address spaces and distinct input and output instructions. That is for if we have an isolated IO. If you have a memory mapped IO, then we have a single set of read and write control lines, no distinct, no distinction between memory and IO transfer. Memory and IO address share the same address space, which reduces memory access range availability. And also, there are no specific input or output instructions. So the same memory reference instruction can be used for input slash output transfers. Examples of this is this. So here we have an example of the input output interface. Now, there's a reason why I'm going through these designs. It means that in the exam, I can ask you to draw. Of course, I probably will not ask you to draw this diagram, but I can ask you to draw this diagram here or this diagram in which we have over here. And you should be able to draw these diagrams. Mm. 1 second, I'm coming. I'm sorry about that. Okay, so programmed IO. Of course, because it is a computer, it means that all the things you'll be doing are programmed, are programmed. So programmed IO operations are the result of the IO instructions written in the computer program. In programmed IO, each data transfer is initiated by the instructions in the CPU, and hence the CPU is the continuous monitoring is in the continuous monitoring of the interface. Input instructions is used to transfer data from the IO device to the CPU. More instruction is used to transfer the data from the CPU to the memory, and output instruction is used to transfer data from the CPU to the IO device. This technique is generally used in very slow speed computer, and it is the and and it is not an effective method if the speed of the computers and the IO is different. So again, here we have an example of this. Of course, we have our interface, which is between them. The interface here, as we now know, is the IO module. So it sits between it here so that the data can be transferred from here to here and then back to front. They are saying that if we want to use the programmed IO, the because the because because the data is sitting on the IO device, it means that the CPU has to have constant communication with the IO device so that it will know what next sequence it should do and how it should execute it. So there is constant communication with the IO device. The IO device and then the CPU have constant communication. They are constantly in, in communication with each other. Hmm? The next major thing we must discuss as part of our lesson is polling or polled operation in computer science, which refers to actively sampling the status of an external device by a client program as a synchronous activity. Polling is the most often used in terms of input-output and is also referred to as polled I/O or software-driven I/O. Again, a concept here, we must look at this concept very, very importantly. If I am saying that the monitor, for example, is going to be used by my computer or the um, pen drive or whatever drive you want to call it, we're going to use those things for our computer. And I am performing actions on them. For example, someone will connect the pen drive, watch a movie from it. Someone will connect a pen and use it for signing signatures in the bank. Someone will connect a camera and use it to be recording or taking pictures and editing the pictures in real time. People use peripheral devices in different ways. If it is connected to the device has to know that it is there. So that at any point in time, if it has a command to execute, it knows that whatever that is connected to it, it has the opportunity to use it. How do I, the computer, know that whatever I'm doing is there and waiting for me so that I can use it? The only way I can know that is by constantly pulling it, constantly checking if it is there, constantly making sure that the status is ready for me. If it is not, then I'll have to look for an alternative because the waiting time is not a luxury for me. It is not something in which I can afford. So I need to constantly make sure that it is available to me and it is ready for me to use. So that is what polling is about. I will be constantly checking to see if it is there or not. Another way I can do this is by using an interrupt. So polling takes up valuable CPU time because the CPU has to be constantly going to check if the thing is there or not. Open communication, open communication only when some data has to be passed, i.e. interrupt. So under the interrupt driven IO, I am saying that I don't have to constantly check if you are there or not. When I need you, I would send a command. And when it gets to you and you give me a reply, then I know if you are ready or not. In that case, I don't have to be constantly pinging you. So we are not in constant communication. I will only talk to you when I know you are there and when I know I need something. Like how most of our relationships are. You realize that there is a friend of yours in your life who will always call you. They will always want to hear from you. They are always in you. They are always communicating with you. But you being a human being, you will say they are worrying you too much and they are in your space. They are worrying you. They are spending too much of your time. So you prefer that when you need something, then you call the person so that the person is not giving you pressure. You see. The person is giving you too much pressure. No problem. The same thing happens to a computer. If the CPU, which is very valuable to us, if you are spending most of this time communicating with a certain device that we may or may not use, there's no point in that. So we can use an interrupt. So when the interface determines that the CPU device is ready for data transfer, it generates an interrupt request to the CPU. So when I am ready, I will send a request that, hey, it's time, I want to come. Can I come? Upon detecting an interrupt, CPU stops and momentarily the task, CPU stops momentarily the task it is doing, branches to the service routine to process the data transfer, then returns to the task in which it is performed. So I will tell the CPU, Charlie, the pen drive has been plugged. Oh. The guy said he wants to watch a movie. Oh. Can we watch? Then the CPU will say, oh, Charlie, you can watch. You bring it, I'll process it for you. Then it will be processed. If the CPU says no, then it means it cannot be what? Processed. The other way around, we are saying that that is the polling way around. We are saying that there's no need for me to send a request. I'll just send it that, hey, it's time for me to watch. And why will that work? It will work because I already know that the CPU is ready for me because we are in constant communication. I'll pause here again. Are there any questions? Are there any questions? Yes.
Say,
Mhm.
please, what if you are transferring data from a pen drive to a computer, but then it downloads to a certain point, let's say 30% of the data, then all of a sudden it says cannot find data. What is the problem that causes it?
When your pen drive says cannot find data, what is the problem that it, what is the problem? What do you mean by what's the problem that caused it not to say find the data or what? Oh, I don't get you.
Say like
Mm-hmm.
say if you are transferring data from your pen drive to the PC,
Mm-hmm.
then you see the IO model will read the data from the pen drive if
Mm-hmm.
it's valid or
Mm-hmm.
then though it's sends a message that is valid, but then it downloads to a certain point, let's say 50% of the data, then it says cannot find data all of a sudden.
Okay. So if I'm understanding you correctly, if I'm trying to transfer data from my pen drive to my computer, during the transfer, it cuts or it stops saying it cannot find data. There are a lot of reasons why this is so. Because I can't go into a computer now and show you, I would show you using the web interface in which we have over here. So in the web interface I have here, if I right click this web interface and go to inspect, so now I'm in inspect. Over here, I am in the network side of inspect. Okay, so in the network side of inspect, I am going to do the same thing I did earlier. So here I'm going to clear. And then over here, I'm going to be in network. So I'm going to clear. Okay, this one, there's no network for me to go to. Let me see. Google. That's great. Let me go to Google. So over here in Google, I'm going to right click and go to inspect, right? And then in here again, I'm going to go to network. Now, in network, there is nothing here. I'm going to type in this, right? Okay. Now, this price in which I've typed here, it has told me that $11,000 is this amount of Ghana cedis. Now, for me to do this, I left, this is my request, the request I made, right? And then this is the payload that I have for my request. So my request was made in Ghana. It was made using a HP computer. It was made using all of these devices. So the information that I am going to send with my request, it is sent to the CPU. So the CPU knows what device it is coming from, what address it is coming from, all of those things, just like this. So that is the payload. So you typing this, you think you have just typed this, but you know that's not true. You've typed the address, you've typed all the other information that goes with this. So here it is. Now, in the transfer of the data, I am going to go to this place, that place, this place, this place, this place, this place, and all of these places until I get to the final request, which is here to show me my response that you see on the screen here. So before I get to the screen here, I have to go through all of these places just so that I can get to the final destination, which is to you. Now, if at any point in time, any of those things stop, so for example, you are transferring your data and then the PC gets a power cut, it means your data has to stop. You are transferring your data and then your pen drive comes out, it means your data has to stop. You are transferring the data and then part of your pen drive is corrupted. It means the data has to stop because when it gets there, it cannot transfer that part. You are transferring the data and then the pen drive in which you are transferring from, for some reason, the pen drive immediately gets bumped out, or you go and click over here and then you click on this button and then go and eject the pen drive or something by mistake. All of these things mean that at that point in time, it has to stop. So you see, the thing is that if you are asking why does it stop, the reasons why it stops are plenty. The only thing here is that there is a reason which will cause it stop. So when it stops, and normally it will stop from either your input end or the CPU end. The CPU end, it is very rare that it will stop from there. Unlike the web example I showed you over here, it doesn't go through all of these places. It will just go from you directly to your input device through the bus line. So it just takes that information and then goes. But for other reasons or for other reasons in which I can't specifically tell you it is this reason, but I can list a number of reasons for you. If the pen drive is removed, if the data is corrupted, if the pen drive is in the wrong format. For example, those of you with a Mac, you realize that if you are trying to transfer data and the data in which you are transferring in a Mac is not in a fat format, it will tell you that the format is not correct, so it will stop. So there are lots of reasons why there would be a stop if there is a transfer between data. And it is there that the interrupt or the polling plays a role. So if there is anything going wrong, it knows that it has to stop and then your operation is going to stop. Prince Kweku, what's your question? Prince Kweku, do you have a question? I don't think Prince has a question. Osborne. What is your question?
My pen drive to the and
Please
after
talk up, okay?
hello, can you hear me?
Pardon? Yeah, I can hear you. Talk up.
Okay. So I was saying, let's say I've connected a pen drive to my machine and then I've transferred data from the pen drive to the machine. After I've removed the pen drive, I'm trying to open the file or data I've stored on the machine, but then it's telling me maybe file something is not found, extension error. What does it mean?
You are transferring data from your computer. And after you've transferred the data onto your pen drive, they are telling
No,
you that, uh-huh,
no, it's rather vice versa.
you are,
Rather me
you are
that
transferring data from your pen drive to the computer.
yes. And
After
after
you
I've removed
After you remove the pen drive, they tell you that the data you transferred onto your computer is not found. No?
yes, exactly. Or
Eh,
there's
means,
an error.
means you didn't finish the transfer of the data. Let,
Okay,
let,
no, maybe the data was successfully transferred, like maybe it came maybe 100%, but then you're trying to still file something cannot be found.
the moment the computer tells you that the file cannot be found, it means that there is no address for it. So it's either either the data was not transferred or it was transferred but not correctly done. So there's no address to it.
Okay.
So you see, one thing in which um, computers, or one thing that makes computers great is that no matter what the scenario is, or no matter what everything gives you, computers don't lie. So if it is A, it is A. Especially those of you who, when you are transferring something from, especially a pen drive to a computer or a computer to a pen drive. So, for example, on my screen here, I can see I have uh, Div C++ over here. For some reason, I don't even know why I have Div C, but yesterday I had to copy it for something. But I have Div C++ over here. And then here, if I am coming to copy this and I press Control C, cut. So I cut it from here and I start the transfer process. And during the transfer process, for some reason, it stops. My data is gone. My data is gone. So it makes sense that if I want to do a transfer of data, I do copy. So instead of me doing cut, I will copy this. I will paste it. And when I'm done pasting it, I'll come here and then delete the copy in which I what did. That makes more sense than the other way around where you cut it. So during the file transfer, if there's a problem, your data would be lost. There is a high chance you lose your data. Yes, Prince, what is your question? Prince Ado.
Sir, please, I wanted to ask that whether the IO model has, it also takes memory from the RAM or it has its own inbuilt RAM, memory. The reason for asking is because sometimes I try to delete very huge files and then when maybe I'd have to pause and go somewhere, I click on pause and then it pauses from where it has deleted to. I can take out the USB or the external drive, go to wherever I want to go. When I come back and I plug it, continuous again. That is what I'm asking for.
At that point in time, the pause is not being saved in the IO module. The IO module itself has a memory system. We can see that from here in the slide, whereby we saw the diagram here. Sorry. Good. So this diagram, we can see the data registers here, right? So the I/O module has in
Yeah.
itself data registers that it uses to store data. So the I/O module has a storage capacity. Of course, it's not huge storage capacity. So the ability for it to save your pause data where you've paused to and all of those things, that is not possible. What is possible is that you are going to, at that point in time, send a command to the CPU that the activity it is doing, it should pause. So your CPU has paused the activity. When you come back and you plug your pen drive in the same location, it is as if it is continuing from where it stopped because the action is being continued. So it is the CPU that is taking control of the action and not the IO device. Does that make sense?
Okay, so in the same location, then it means in a different port, it's not going to continue.
It's not going to work. So if you not in a different port, in a different location. For example,
Okay.
if you plug your pen drive up, right? You see that you are
Yeah.
given an address, let's say drive D or drive something, right?
Yes. Yes.
Now,
Yes.
if you remove it and you plug another pen drive, that new pen drive will come and take the drive D. So if you plug
Yeah.
your previous pen drive, that will become drive E or something like that. Now,
Yes, sir.
if your pen drive's address has changed, now drive E, it won't work. It will assume it is still drive B. That
Okay.
does that make sense? Mm.
Yeah. Yeah.
Cyril, what is your question? Oh, sorry, I said Cyril. Cyprus. Is it Cyprus? Cyrus. Yes, sorry. Cyrus, what's your question?
Hello, sir.
Yeah, hello.
Please, my question is, I'm having this pen drive. Whenever I place it inside PC and I transfer um data, which is a file that is not a video. Whenever I transfer that, I'm able to access them when I bring the pen drive out and put it inside another PC. But when I transfer videos to it, what happens is that I'm able to use the video when the pen drive is still inside the computer. But the moment I bring the pen drive out and place it back inside, that video file will be corrupted, except for the music files. The music files will also be corrupted, except for only the image files and the rest.
Are you sure your computer doesn't have a virus?
Please know I've tried with other computers, and that's the same result that the pen drive gives.
Then check the pen drive format. If it is FAT or NTFS.
Okay.
If
Okay.
it is FAT has a size range. So if the size is over the limit, it won't work.
Okay. The size is 4
Not
megabytes,
the
8
size
gigabytes.
of the not the size of the uh,
The capacity of the pen drive.
not the capacity of the pen drive.
Okay.
I'm
Okay.
talking about the over here when you no, not here. 1 second.
Okay.
Um, over here. In the properties, or I don't have any pen drive plugged, but in the properties of your pen drive, like here, for example, I can see
Okay.
that my drive is in NTFS format.
Yeah.
Can you see that?
Yes,
Your
please.
pen drive, check the format it is in. If it is in FAT or NTFS.
Okay. Okay.
Hmm. I guess those are all the questions, right?
Yes, please.
So let's continue and finish up very quickly. Yeah, here. Now, even though you can use the interrupt to um, give commands and locate the devices in which we want, we should know that sometimes there is priority. The same way whereby when you are on the road, there is priority given to special ambulances, special workers, and so on and so forth. The same way the computer also has priority, and sometimes the priority of the devices also takes into effect. If I plug up a pen drive and I plug up a printer and I plug up a monitor all at the same time, one of them is more important than the other. Let's not be deceived. In this life, we will tell ourselves that we are all important, but there are people who are more important than you, if we like it or not. For example, if Ghana was burning and the entire country is burning and they have a helicopter there, the president will go inside before you enter. Ta-da! So there is importance placed on individuals. There is importance placed on certain things. So for the same reason of that, there is priority. So we can see that here we have priority interrupt by software. That is by polling. Priority is established by the order of polling the device. That is identifying the highest priority source by software needs. That is, each of the devices you are connected to, even though I'm constantly checking all of them to see what they are all doing at the same time, if one of them or if all of them need access to the CPU at the same time, I have to now select which one is of more importance to give that individual or that device the highest priority so that it can do what it can do at the quickest possible time. Does that make sense? So the way in which priority is calculated or it's done is by using the gates. So we use the gates to establish how priority is done in a particular device. So as we can see here, we can see that using the truth gates, we only get you being prior or having priority if you meet all these criteria. And what does this tell you? It means priority is an AND gate. So we have 1, 1, 1, all of them being true before you have a what? A true over here. So the rest of the slide is readable or it is acknowledgeable. So you can go and read on it. I just had to introduce to you what input-output module is and the important concepts that are in it. I have already sent you this PDF. It is readable. It's not very difficult to comprehend. That's why I sent it to you. You can just read it off and then be done. You can use since most of you have very busy lives, you can use the rest of the time in this class to just read the 19-page document and get it out of the way and make some small notes out of it. If you have any question, you can drop it inside the group. Class rep, I understand that the revision week is like 3 weeks ago. It's not next week. So next week we have class. Is that true? It's always there.
So yes.
So I understand.
I heard it's next week, the revision.
Are you sure? I asked a friend and he said next week there's class or something. Well, okay, you during the week, let me know so that if there's class,
Okay.
I'll see if you can come on. What you do.
Okay.
I would be putting in some questions for you in the class group so that you can have a look at it. Okay. So you can start preparing for your exam or whatever. And those of you without a school ID card, they said they will use the school. I sent you the message. They said they will use the school ID card for the exam. So make sure you bring it when you are coming. And if you don't have one, make sure you go and get one before the exam time. You have enough time now to do that. And I'm supposed to help the quality assurance people by telling you people that there is a lectures evaluation form or whatever during the revision week period. Try and log into your ERP and do the lectures evaluation for all your teachers. Also, when you go to the lectures evaluation site and you don't see any course there, it means you have not registered for the semester. So make sure those of you who are here because of school fees and all of those things, you have not registered. By the end of this week or next week, you go and make the payment and register. Don't just go and pay the fees. Pay and register. It's very important. The registration is even more important than the fees in which you are going to pay. You can see some of your seniors or the people ahead of you suffering with result issues. Don't be one of them, please. Go and get yourself registered. Make sure all your courses are registered. Make sure you have a printout of the registration so that if any case comes, you can show your printout. Keep all your receipts. Please, please do that and make sure you start getting yourself ready for the exam. For those people who are asking me about attendance, blah, 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 forget it. The first eight minutes, those who were here for the first video, yeah, I didn't say anything. When I just came on, just started the class. And before I came on, I had already taken the attendance when I don't need job. So, and then J Fort, plus, if you want to dash marks, you don't dash marks to plenty people, only small. So the small people who came early, the small people, yeah, we dash them the mark. And then someone wrote there, say if after downloading an application, all is what do Bismarck, I don't understand what you've written on. So if you could unmute and tell me, I'll be grateful.
Oh, okay, sir. It's like yesterday I was downloading an app,
Okay.
and after downloading the app, when I'm trying to install it, it just opened a dialog where it asks me how do you want the file to be open, and instead of maybe various, let me say, apps for you to open the app, it displays look for an application in the Microsoft Store. Is that the cause of the IO module point?
Oh no, that's not a cause of the IU module content. By law, Microsoft was sued because of Internet Explorer. Internet Explorer had almost 90% of the market. And the reason they had 90% of the market was that people are lazy. So when they buy a computer, Microsoft Explorer is the browser that is there. So they just use the browser that is there. So the other companies were saying that there is no competitive balance. So in order for competitive balance to be there, that is why nowadays when you install a new app, they ask you, which one do you want to use? Then you select the one you want to use. So for example, if you have a I don't have any video files on my computer, do I? So I don't have any video files on my computer. Okay, I have a video file on my computer. So if you have this and you right click here, of course, when you go to open with and then you come here, I'm sure this is what you're talking about. They ask you which one you want to open with, and you have to go and choose a file you want to open with. So if you have chosen the wrong file, just go to open with and then go and select the right one. But this has absolutely nothing to do with the input output stream. It has everything to do with the OS and they being legally obligated to give variety so that everybody will be given a shot. Anyway, any more questions? So if there are no more questions, then thank you very much. Elvis and I will have a chat during the week to know if we have class next week or not. If you don't, if you have a question, you can put it in the class group. I'll make the class group open so that anybody can comment. Please, only comment if you have a question. If you have a question, then you comment. Then you can answer them and then people can see the answers so that you can help them, so on and so forth. If there are no more questions in the group, then I will end the Zoom so that we can go and continue with our busy lives. Any more questions? All right. Thank you very much. We would meet again next week if there is class. If there is no class, then we will meet on the WhatsApp page. Yes. Oh, hello? Are you there? Before you go, you must discuss the exam question here, right? Let's do it now and get it out of the way. So the examination questions are going to be over 100. They are broken down into 3 sections. We have section A, we have section B, and we have section C. Section A is 20 marks. Section B is 30 marks. Section C is 50 marks. 50 marks in total. Section A is objectives only. Do all. Section B is calculation questions only, like performance, speed, cash, right back, right through, those things only. There are 4 questions there. You are to do 3. Each one is 10 marks. The final one is writing. There are 4 questions there. You are to do 2 or any 2 in which you want. And each one is 25 marks. I'll pause here for any questions or suggestions.
Sir,
Yes.
please, is it possible that one of these coming days you can go back to the calculations, then we do a little bit revision?
But if next week we have class, we can do that. We can go over the calculation for the what do you call that thing? Performance, speed, Amdahl's law, and so on and so forth.
Yes,
Nothing,
please.
nothing will come under what do you call that thing? Gates. There will be no calculation questions under Gates, Maslow's law. So break it down. Those questions, nothing will come over there. So they'll more be on how to calculate performance and so on and so on. Is that okay?
Yes, please.
Okay. So if there will be class next week, or if you guys want us to come during the revision week, we can do online again, or we can come in person and then do the calculation. It's not a big deal. Any questions again? All right. If there are no questions, then thank everybody for coming. We'll meet again next week. Bye bye.